So the main idea is to form the quadratic equation. So the main idea is x squared minus sum of the root x plus product of the roots equals to 0. This is the main idea. Now, in order to do that, they're going to give an information. That information is going to help us simplify, and this is the additional information. It has nothing to do with the sum. It just have additional information. So that means this information will be given if ax squared plus bx plus c equals to 0 is a quadratic equation, then, and if we know that one of the root is alpha and the other one is beta, then we can write that the sum of the roots of this particular equation is minus b by a, and the product of the root of this particular equation is c by a. So this information is mainly given to make the algebra simpler. So let's start. So this is the first question. So the roots are given. So number 1. So the sum of the roots. So 1 is 2 alpha cubed plus 2 beta cubed. So we have to find the sum of the roots. So we can take 2 common and it becomes alpha cubed plus beta cubed. Now we need to use these two information, the information of alpha plus beta and alpha into beta, to do the sum. So before actually doing this, we need to find the value of alpha plus beta and alpha into beta. So we can write, we know from this, so alpha plus beta is minus b by a. So minus b is 4 divided by a is 2. So this is minus 2. And alpha into beta is c by a by this rule. So c is 5 and a is 2. So 5 by 2. So now we can continue with our sum. So now we have to find out the value of alpha cubed plus beta cubed. So we can write, so alpha cubed plus beta cubed. So remember the identity. So this is an algebraic identity that you need to remember. So this is the identity. A cubed plus b cubed is identical to a plus b multiplied by a squared minus alpha beta plus b squared. So this is the identity that we have to follow. So we can write alpha plus beta times alpha squared minus alpha beta plus beta squared. So alpha plus beta we already know is minus 2, and alpha squared plus beta squared is some value we need to find. So for that we have another identity, and that identity is a squared plus b squared is identical to a plus b whole squared minus twice ab. So you need to remember this particular identity, both of them. So this is going to be, so alpha squared plus beta squared minus alpha beta. So alpha beta is 5 by 2. Let me keep 5 by 2 over here. This would be minus 2. So alpha squared plus beta squared is alpha plus beta whole squared minus 2 alpha beta. So minus 5 by 2, we already put the value before. So this would be minus 2. So alpha plus beta whole squared is minus 2 whole squared, and minus 2 alpha into beta is 5 by 2, and we have this minus 5 by 2 over here. So we can write it as minus 2 squared is 4, and this 2 and 2 cancel. This would be minus 5 by 2, and the value turns out to be, so it turns out to be 7. So this value would be 7. So we have found the value of alpha cubed plus beta cubed. So we originally wanted to find the sum of the roots, which is 2 into that. Therefore, so 2 into 7 equals to 14. So this is the sum of the roots. Now we need to know the product of the roots. So let's find that. So let's find the product of the roots. So product. So the first root is 2 alpha cubed, and the second one is 2 beta cubed. It turns out to be 2 to the 4, and alpha cubed times beta cubed can be written as alpha beta whole cubed. So this is alpha beta is 5 by 2, so 5 by 2 whole cubed would turn out to be 4 into 125 divided by 8, and it turns out to be 125 divided by 2 if you cancel it with 4. Now we have to find the root, find the equation, the quadratic equation. So it would be hence x squared minus sum of the roots, it would be 14x plus product of the root, it would be 125 by 2 equals to 0. In order to make it integer coefficient, we can multiply both sides with x, both side with 2. It would be 2x squared minus 14 to the 28x plus 125 equals to 0. This is the quadratic equation. Now we have another part over here. Here we have 5 by alpha cubed and 5 by beta cubed. So when we have this, let me do it over here, sum 5 by alpha cubed plus 5 by beta cubed. So when we take the LCM, it is alpha cubed beta cubed. So this would be 5 beta cubed plus 5 alpha cubed. Now we don't have to do the sum all over again. We already found the value of alpha cubed plus beta cubed, which is 7. We can just plug it in here. So what we can do over here is we can take the 5 common, and alpha cubed plus beta cubed is 7 divided by, and we also know that alpha cubed beta cubed, this value from the previous sum, alpha cubed beta cubed, that is 5 by 2 whole cubed, which is 125 by 8. And using the calculator, it turns out to be 56 by 25. So 56 by 25. So this is the sum of the roots. Now product of the roots. Product of the roots would be 5 by alpha cubed times 5 by beta cubed. So that would be 5 into 5 is 25, and alpha cubed times beta cubed, we have found it as 125 by 8. So this would be 125 by 8. So again, using the calculator, we'll get, so 8 by 5. So we can write this as 8 by 5. So now we are ready for the quadratic equation. We know both the sum of the roots and the product of the roots. It would be x squared minus sum of the roots, which is 56 by 25. Then we write x plus product of the root, which is 8 by 5 equals to 0. Now in order to make integer coefficient, we have to multiply both sides with 25. So that this 25 and that cancels. So 25x squared minus 56x plus, now 25 by 5 is 5, 5 8 is 40. So let's review everything that we have done so far. So the first thing is we have to form a quadratic equation when the roots are given. So that would be x squared minus sum of the roots x plus product of the roots equals to 0. That is the main idea. Now in order to simplify the roots, because the roots would be given in algebraic symbols, usually alpha squared, beta squared, something like that, they're going to give us some information, and that information is going to be in the form of another quadratic equation which has nothing to do with the quadratic equation we have to find. So they would give that a quadratic equation has two roots, x1 equals to alpha and the other one is x2 equals to beta, and using this information we need to know the value of alpha plus beta. So alpha plus beta is minus b by a, and alpha into beta is c by a. So this information would be given so that the algebra becomes easier. Now there is another information that we need to know, is the identities, the algebraic identities. So the algebraic identities are, first of all, a squared plus b squared is identical to a plus b whole squared minus twice ab. Then a cubed plus b cubed is identical to a plus b times a squared minus ab plus b squared. And then we have a cubed minus b cubed is identical to a minus b, a squared plus ab plus b squared. So these three algebraic identities, will help us to simplify the sum of the roots and the product of the roots. Now there is one more thing that we need to know. If it is a minus b, we can write it as square root of a minus b whole squared, so that the square root and the square cancels off. So the question would be, we would be given two roots. So one would be in terms of something alpha alpha square or something, another one would be given in a similar fashion. So we have to find the sum of the roots. We have to find the sum of the roots, and we have to find the product of the roots. And using the sum and the product, we have to form the new quadratic equation. Now in order to find the sum and product, we need to simplify it, and we need this information alpha plus beta and alpha into beta, which would be given with the help of another quadratic equation which has nothing to do with this new quadratic equation. They would be given to make the algebraic process easier. Now we need to simplify these terms so that they look like alpha plus beta and alpha into beta. For that, we need to use these identities, and that's the structure of the sum.